Guys, I know that chapter 17 is really hard stuff, and we're only on the third section, but hang in there because in my opinion, chapter 17 is the hardest chapter that we cover in 163. So, hey, at least we're getting it over with early. It's not like the last chapter that we cover. So in 17.3, we're going to talk about acid-base titrations. And if you're working on the labs, you've already done a titration already. So you've kind of played around with it a little bit. A titration is a lab technique. And it is used, well, it's got probably a few different purposes, but for the most part, it's used to determine the concentration, like the molarity, of a solution. So, like, practically thinking, this could be something, let's say that you were working in a lab and one of the services that your lab provided was water quality testing. So somebody could send in a sample of their tap water and you could determine how much iron was in the water, like what's the concentration of iron ions in that water, or really anything that you wanted. You could figure out what that concentration is. In order to be able to do a titration, you need to have two solutions. So a titration uses two solutions. And initially, the two solutions are separated from each other. So get excited because I'm about to draw titration setup. The titration uses two pieces of glassware. And one piece of glassware is this really long, we've used them in lab before, but maybe you forgot. It's a few feet long, skinny glass tube. It's got a nozzle down on the bottom of it. It says open up here on the top. And then it has this valve type thing that you can use to seal it off down at the bottom. And that this valve thingy is called a stopcock. So you can rotate the handle on the stopcock and it opens and closes the flow of the solution through this burette. You fill the burette from here, so a solution goes in here. We're going to call this solution A, and just going to fill it up with solution A. And all of this is being clamped up, so it's staying upright, and solution A is going to, once the stopcock is open, solution A is going to come out the bottom of that. And then your second piece of glassware that you use is an Erlenmeyer flask. Or you could do it into a burette. But I like to titrate into an Erlenmeyer flask. And this is probably the best Erlenmeyer flask I've ever drawn in my life. The Erlenmeyer flask has another solution in it down here. So in the Erlenmeyer flask, this is solution number 2. We're going to call this one solution B. And in the titration, we are just going to allow solution A to drop down into solution B, and they mix and they react. And they react in a reaction that we understand. That's one of the criteria of a titration, is that we have to understand how A and B are going to react. So solution A up in the burette, typically, not always, but typically, that solution has a concentration that we know. So we're going to call that a known molarity. We know what the concentration of that solution is. And also for the solution A in the burette, because the burette has volume markings on it. It's got like little volume markings that we can read as we drain the solution out of the burette. We're able to like figure out what the volume is of the solution that we have drained. Oh, that was too much erasing. We can figure out how much we've drained out, so we can figure out the volume of the solution that we used for the titration. So we just kind of monitor as we drain solution A out of the burette, we monitor the volume change, and we use that to figure out how much of solution A we've drained out of the burette. So we know that about solution A. And then the other solution, solution B, in the Erlenmeyer flask, this is typically the solution that has the concentration that we're trying to figure out. So this one has an unknown molarity. So maybe down in the flask, the green solution, maybe that's somebody's tap water and we're trying to figure out how much iron is in there. So it has an unknown molarity that we're testing. And this solution in the burette also has, or excuse me, in the flask, it also has a known volume. And we're going to control that because when we put solution B into the flask, we're going to measure how much of that solution goes into the flask. So we will know its volume. So again, solution A, we know the volume. Solution B, we know the volume. Usually in the burette, we also know the molarity. And in the flask, we don't know the molarity. Now I keep saying usually we know the molarity of the solution in the burette. If we don't, so if in the burette the molarity is the unknown, we don't know what that is, that means that the solution down in the flask has to have a known molarity. So only one of these two solutions can have an unknown molarity. So that's kind of the setup of the titration. And there are two different types of titrations between acids and bases. So there's two types of acid-base titrations, and there are many types of titrations in general. But for now, we're just going to focus on acid-base titrations. And the two different types of acid-base titrations would be titrating a strong acid with a strong base. So that could mean maybe we put a strong base up into our burette, and it's got a known volume and a known molarity, and we put a strong acid down into the flask, and we mix the two together. So that would be one type of acid-base titration, and that's going to be the first type that we talk about. The other type of acid-base titration is a strong acid or base with a weak acid or base. So this could be strong acid plus weak base, or it could be strong base plus a weak acid. So maybe we could modify this. Maybe we have a strong base up in the burette, but we have a weak acid down in the flask. And this strong plus weak titration is going to be the second type that we talk about. We are not going to talk about weak acid, weak base titrations. We're just avoiding that completely. That's generally way too complicated. So what we're going to look at next is these two types of titrations one at a time, how they work, and what type of data we can get from them.